Hello, my name is METİN. This is 215 part of explanation of my theory. Yes. According to my theory and my formulas, Planck's constant is not a constant. 1. As I told you before, Planck's constant is nothing but the angular momentum of any arbitrarily chosen inseparable point of an electron motion form of matter sensation perception matter. We can say this inseparable point of surface of electron motion form is the photon. Electron motion form is intrinsic motion form, perpetual, ring-shaped, cyclical, spherical motion form of matter sensation perception matter, and its successive waves, same types also. Yes. As I told you, and as I showed you before, for an at rest, not in motion, 91.155 nanometer wavelength size kind free electron motion form, angular momentum of any chosen inseparable point of this free electron motion form is the same. Angular momentum is the same for each point if electron motion form is at rest. And I have put forth that Planck's constant is angular momentum of electron motion form, like this. Here, speed of light direction, component angular momentum, mass 2.42 10 to the minus 35 kilogram. Here 1,884,000 kilometer per second Vc direction component angular momentum is the same. When it is at rest, here 6.62 67 10 to the minus 34 kilogram meter per second. Here c direction mass of electron motion form, and this is 91.155 nanometer wavelength size and speed of light, and here linear velocity direction mass 6.28 times greater than speed of light Vc multiplied by lambda normal initial wavelength of electron motion form is the same. Angular momentum or Planck's constant, okay? Now, when a free electron motion form is at rest, for all wavelength size kind at rest, not in motion, electron motion forms angular momentum is the same. L is the H is the 6.62 60 70 15 kilogram meter squared divided by second. Planck's constant. Yes. 2. As I told you before, whether a free electron motion form, as the successive light waves source is at rest or in motion, for each wavelength size kind of electron motion form, the specific frequency is constant. Here, at rest electron motion form. Okay, at rest. Here, in motion electron motion form, moving electron motion form, but the frequency is the same. Okay, this is this place I wrote. This is my constant frequency equation here. Yes. Although when the free electron motion form relocates, moves its point wavelengths and point energies and point masses, point velocities are variable. Frequency in each cases at rest or in motion electron motion forms is constant. For instance, here it is constant. This is electron motion form in this 0 degree direction, motion direction. Each point, successive waves or electron motion form have different wavelength, different energy, different mass, different wavelength, different wave velocity, and I will show you now different angular momentum. When a free electron motion form is in motion, angular momentum is not conserved and Planck's constant is not conserved and Planck's constant is not constant. Yes. No. Yes. 3. When a free electron motion form is moving, angular momentum cannot be conserved, and for any arbitrary point of free electron motion form surface, L angular momentum or H is variable. Planck's constant is variable. For instance, for moving 91.155 nanometer initial wavelength, yes, 91.155 nanometer initial wavelength, size free electron motion form at don't notice these numbers, okay? This may be different numbers. Only notice the shape, okay? For instance, for moving 91.155 nanometer initial wavelength size free electron motion form at 258 258,927 kilometer per second. Velocity For instance, for moving 91.155 nanometer initial wavelength size free electron motion form at 258,927.1 kilometer per second. Okay, velocity in the 90-degree direction, its point wavelength is 91.155 nanometer. Okay, like this. Okay. At this point, 91.155 nanometer, 90-degree direction. Okay. Its point wavelength is 91.155 nanometer. Say in 25-degree direction, this is 0-degree direction. Electron motion form is in motion in this direction. Okay. Wavelength will be shortened here. Here, 0-degree direction, shortened wavelength. But at this point, okay, 25-degree direction, from this to this point in motion, a point, motion form, electron motion form, motion, yes. For instance, for moving, okay, 91.155 nanometer initial wavelength size free electron motion form at 258,927 kilometer per second. Okay. What? Okay, in this direction. Here, wavelength is 91.155 and point wavelength. And point velocity is the speed of light, c, and point energy I will compute now. And in motion, this point at this 25-degree shortened wavelength at 25-degree point, what? Its point wavelength is 91.155 nanometer. Then, in 25-degree direction of motion direction is point wavelength. Okay, its direction, its point wavelength is 1985, 18 nanometer. Okay. Again, at this point, shortened wavelength in 25-degree direction, shortened wavelength is, I have computed according to my theory and my formulas, what? 19.85, 18 nanometer. Okay. Here, at this point, 91.155 nanometer wavelength, and corresponding energy is what? 90-degree energy is what? Yes, 21.79 10 to the minus 19 joules or kilogram meter square per second square. In the 25-degree direction, 19.85 18 nanometer corresponding energy is what? 100.09 10 to the minus 19 joules. Greater than this, okay. But frequency is the same. Don't forget, frequency is the same. What is frequency? Frequency is, I have computed, okay, 3.29 10 to the plus 15 1 divided by a second. Frequency is the same. Okay? Yes. Yes. Interesting. There is irreconcilable contradiction. For instance, for moving 91.155 nanometer initial wavelength size free electron motion form at 258,927 km per second in the 90-degree direction, its point wavelength is 91.155 and its corresponding energy is 21 10 to the joule. And okay, in 25-degree direction of motion direction, its point wavelength is 19.85 18 nanometer and its corresponding energy is 100.1 10 to the minus